Now we're in section 5.2. In this section, we're going to take a look at adding and subtracting, multiplying and dividing decimals. In the summary, we can see that more clearly here. Adding and subtracting decimals, multiplying and dividing decimals, and using decimals in money applications here. So let's take a look in 5.2 and see what we find out. So in the first place here, when we look at adding and subtracting decimals, you add and subtract decimals pretty much the same way, except you have to be sure to make sure all the places line up evenly. And if there are places missing, you want to use zero placeholder here. So you can see in this example, when they're adding money, notice how the decimal points are all lined up, and they go out to the same places here. Setting up the problem is so important before you do your computation. Set up the problem first completely before you do your computation. So this particular problem here, in this first one, they want us to add these two numbers. So the first thing we do when they add the two numbers is set it up so that the decimals align on top of each other. This is important because you want to make sure you add the tenths and the ones that you add it correctly. Then you add it as if they were whole numbers. 7 and 4 is 11. You put down your 1, carry 1 over. 3 and 2 is 5, plus 1 is 6, and then you have your 1 here. Then you bring your decimal down. So you add them as if they were whole numbers. But before you add them, you want to make sure you line your decimals up. Make sure everything goes out to the same place. Now this one here, notice 23.5 goes to the 10th place, and 41.38 goes out to the 100th place. So when you add them up, they're not even. So what you do is you go ahead and you add a zero placeholder here in the beginning. As I said before, set up your problem first completely before you do your computation. Don't try to solve it and set it up at the same time. So now you have the hundreds. You have your tenths represented. And you can go ahead and add it. Notice the decimals are lining up. From the beginning, the decimals are lining up. So now you add it as if they were whole numbers. And you put your whole number back in the end result here. It's a good idea to at least know how to add and subtract whole numbers without a calculator. Because you never know, you might have to do so many problems. And you may not have a calculator available to you. And this one here is subtracting. So when you're subtracting, they put the decimal in here for 20, but they have nothing after the decimal. So you got to put in 2 zero placeholders here. So now they both go out to the hundreds place. Then you do your subtraction, and you subtract as if it was whole numbers. You can't take away 5 from 10, so you got to borrow. So now notice here, everything is going to roll back at least 1. So to begin, they had 20, and then they have here 1465, and they're subtracting. So 20 doesn't go out to the hundreds place, so they put zero placeholders here. So now when they're subtracting, you subtract as if they were whole numbers. You can't take away 5 from 0, so you got to borrow 1. So when I borrow 1 here, everything's going to roll back 1. 10 minus 5 is 5. 9 minus 6 is 3. 9 minus 4 is 5. And then you have, what's that going to be? 1 minus 1 is 0, so I have 5 here. 535. Here's another one. It's subtracting. So they have 2.51 minus 7.4. So they don't go to the same place. Okay. So how did they switch? What happened there when they switched it? Well, remember now, we have 2.51 minus 7.54. So I have a positive here minus a positive here. If I do a keep change on it, I have something like this. 2.51 keep change, so that becomes a plus and a negative. Five, 7.4. So when I subtract, I'm going to have a negative 7.4, and going to be plus 2.51. So what's the rule when you're adding two numbers? When you're adding two numbers and they have different signs, subtract the smallest from the larger and take the sign of the larger. So I have 7.40 minus 2.51. You subtract it like it was a whole number, and you take the sign of the larger. Okay. And I end up with 4.89. And I take the sign of the larger, which makes it a negative 4.89 for my final answer here. So the rules still apply. Which is another reason I said you have to know those rules for adding and subtracting and multiplying integers. Another way of looking at that is if I'm 2.5 feet in the air, and then I go down 7.5 feet, how far in the hole will I be? And that's another way of looking at it. Okay. Now we're going to look at multiplying decimals. Now when you're multiplying decimals, just like before, I said that you ignore the decimal point and just go ahead and multiply it as if they were whole numbers. For example, here, if I had a 0.3 and I had a 0.7, I count the number of places past the decimal. So I have 2 places past the decimal. So 3 times 7 is 21. Okay. And then I go ahead and I shift by decimal point the number of places. 1, 2. So my final answer is 0.21. So you can see that there. Okay. Another one here. They have 0.2 and they have times 0.46. 1 place past the decimal and the 2 place passes the decimal. Okay. And 2 times, then you multiply it as if the decimals weren't there. 2 times 46 is going to be 92. And so now I have to count the number of places past the decimal, so I have a total of what? 3 places here. So I shift the decimal point. 1, 2, 3. So my decimal point goes there. My final answer is 0.092 for my final answer. Let's look at some more examples here. So when they set this up, they didn't have to go ahead and add any placeholders in here. You just count the number of places past the decimal and multiply it as if they were whole numbers. So if I have 4.075 times 3.9, I see I have 3 places past the decimal here, and I have 1 place past the decimal. Then I multiply as if they were whole numbers. Okay, so I end up with 36675. Then I shift it over 1 place, and I have 5, 2, 2, 2, and a 1. We add these up. 5 here, 2 here, 9 here, 8, and then 15. So then I have to count the number of places past the decimal, which is 4. So right now my decimal point is there, and I shift it over 4 places. 1, 2, 3, 4. Decimal goes there. My final answer is going to be 15.8925. That's my final answer. So for this one here, we're multiplying, and we have a negative times a positive. So we already know that a negative times positive is going to be a negative. So my final answer is going to be negative. So now you can go ahead and just multiply it out. You have 8.2 times 5.19. So I have 5.19 here. Then I have an 8.2. Count the number of places past the decimal. And then I count the number of places past the decimal. And I multiply it out. And I shift it over 1 place. I'm multiplying. And then I have 2, 5, 1, 4. Then I add them together, and I have 42, 5, 5, 8. My decimal's there, and I shifted it over 3 places, so I have to shift this over 1, 2, 3 places. So I have 42.558. Okay. This one here I'm multiplying out. So I have here 3 places past. Let's multiply this one out here. So I have 0.045, and I'm multiplying 3, 0.0. Number of places past the decimal. On the top one's going to be 3 places, and this is 1, 2 places. So we're multiplying here. So we're going to have to be shifting this 5 places in the end. So we multiply this out. Okay. So we multiply this one out here, and we have 3 times 45. It's going to be 135. And then after that, everything else is going to be zeros. So I'm going to have zeros out here. Now, because 0 times all that's going to be 0, so in the end we're going to have a decimal right there, and we have to shift it over 5 places. 1, 2, 3, 4, 5. So I'm going to have 0.00135 for my final answer. This one is showing multiplying by powers of 10. Notice here, in this example here, they have a 0, and then you put 1 0, then you put everything else after it. Then multiplying here, they put the 2 zeros down. Then they put it times 1, everything else after it. Over here, they're multiplying by 3 zeros. Then you put 3 zeros down, multiplying by everything after it. It might look a little bit peculiar, but imagine this. times 10. Put 1 0 down, then I say 1.9 times 436. Have the same thing there, or 19 point. The decimal is going to be, let me do that one again. So I have 1.9436, and I have 4 places past the decimal here, times 10. Put down my 0, then I have 6, 3, 4, 9, and a 1. And I shift it over how many places? 4 places. 1, 2, 3, 4. And I end up with 19.4360. There's your answer there. And let's look at another one. So here I have 1.9436 times 1 times 1. 36 times 100. So I put 0 there, a 0 there. Now I put my digits down, right? 6, 3, 4, 9, 1. Now I'm 4 places past the decimal. So I shift this over 4 places. 1, 2, 3, 4. So I have 194. Let's do one more now. I have 1.9436 times 1,000. So 0, 0, 0. Put my digits down, right? So 3, 6, 3, 4, 9, 1. And the decimal's right, and I shift it over 4 places past the decimal. So I shift this over here. 1, 2, 3, 4. So I end up with 1943.6. 0, 0, 0. 0. Okay. Notice here when they're multiplying it by 100, they shifted it over 2 places to make it larger by 2 places. 2 places to the right. Multiplying it by 100, we shift it over 2 places to the right, makes it that much larger. Multiplying it by 1,000 will be shifting it over 3 places to the right. Multiplying it by 10,000, shifting it over 4 places to the right. The most common one is multiplied by 100. You always shift it 2 places to the right to make it that much larger. So now they're looking at here what happens. Examples of multiplying by 100, by tens and hundreds and thousands. So as a quick way of looking at it, when you're multiplying by, you have 5.63. Multiplying it by 10, it's going to make it 10 times larger. It's going to shift it over 1 place, which will make it 56.3. If I have 5.63 times 100, I'm going to shift it over 2 decimal places. 563. The next one here, they have 5.63 times 1,000. So I'll shift it over 3 places. So I have 5630 point. Okay. Sometimes you have to add a 0 here. Now we look at dividing decimals. Dividing by a whole number. Now, generally speaking, when you're dividing by decimals here, it's easier to divide by a whole number. Because when you divide by a fraction by a fraction, it can get kind of complicated. So what they try to do is shift the decimal point so you're always dividing by a whole number. In this case here, we're dividing by a whole number. So we're doing long division here with decimals. So we have 0.12 divided by 3. So I'm going to have 3 going into 0.12. So I put my decimal point right above it, and I said 3 won't go into 0, 3 won't go into 1, 3 will go into 12 4 times. 3 times 4 is 12. 12 minus 12 is 0. So my answer is 0.4. This is what we're dividing. They're dividing 399 divided by 24. Notice you put the decimal right above it. You separate the whole parts from the fractional parts. 24 will go into 3 0 times. 24 will go into 39 1 time. 1 times 24 is 24. You subtract. 15 you bring down. 24 will go into 159 6 times. 6 times 24 is 144. You subtract, you have 15. Then you bring down. Okay. Go into it 6 times. Okay. So when do we stop here? It's not ending. So in this case, since we're dealing with money, we stop after the thousands place, because you want to round to the nearest penny. So you go take your division out to the thousands place. So you can round to the nearest penny, which will make it 17 cents. And this next one, you're dividing a decimal by another decimal. So in this case here, we have 0.08 divided by 0.2. We have a fraction divided by a fraction. So what we really have here is 0.08 divided by 0.2. So what we really have is 8 tenths divided by 2 tenths. Okay. As it turns out, the 8 and the 10s cancel out, and we have 8 over 2 here. Now we're dividing by a whole number, which is 4. So when you're dividing with long division here, an easier way to get this done is to go ahead and to use, remember to shift the decimal point the same number of places. So notice in this problem here, we have a negative 2.89 divided by 3.4. We have a negative divided by a positive. So my final answer is going to be a negative here. So let's take a look at dividing. 3.4 divided by 2.89. Okay, so I put my decimal point right above it. So 3.4 divided by 2.89. Notice I'm dividing by a fraction here. Really I'm dividing by a mixed fraction. So I want to shift my decimal, so I'm dividing by a whole number. I have to shift it one place. And if I shift this one place, I got to shift this one place. So now I'm going to be saying 34 divided by 28.9. Okay. That's what you have to do. 34 will go into 28, but 34 will go into 289 8 times. You can see that here. We're going to it 8 times. Okay, indeed, divided like they were whole numbers. So since we know that our final answer has to be negative, we have a negative 0.85. So when you're dividing here, a negative divided by a negative is going to be a positive number. So we already know the answer is going to be positive. So for this one here, you can't divide by a fraction, so we shift it to divide by a whole number. In this case, I shifted over 2 places. So I'll rewrite it. Now, what I find a lot of students will do is they won't take the time or the effort to rewrite the problem. Go ahead and take the time and effort to rewrite it here. This is important, because it can get really messy and you can go make a mistake that way. So after you shift it, remember to shift the decimal point. In this case 2 times, so you shift it 2 times in here. Don't forget to put the decimal point right above it, so you know, separate the whole parts from the fractional parts. Then you follow it as if you're dividing whole numbers. 6 goes into this. You end up with 427.5 here. Now you have 4 being divided by 0.05. So I'm divided by a fraction, so I have to shift it to make it a whole number. I shifted 2 places, so on the inside I shifted 2 places. So now once I've done that, I know where the decimal point is going to be. Take the time to go ahead and rewrite it before you do your division. In fact, that's what they did here. They rewrote it. They rewrote it. Then they did their division. Now we're looking at decimals in money applications. Decimals in money applications. Paul received $50 for his birthday. He spent $31.64. How much is left? That sounds like a subtraction problem to me. So we have here $50 less $31.64, subtraction. So Paul has $18.36 left. Jesse put 8 gallons of gas in the car. 1 gallon costs $3.05.29. How much does Jesse owe for the gas? Round to the nearest penny. So if each gallon costs $3.50, and they got 8, that sounds like a multiplication problem. 8 times. Then they want you to round to the nearest penny, makes it 23 cents. A lot of times, in most cases, it's a good idea to go ahead and do your rounding at the very end. If you round early, it throws your answer off. Four friends went out to dinner. They shared a large pizza and a pitcher of soda. The total cost of the dinner was $31.76. If they divide equally, how much should each friend pay? Okay. Total cost is $31.76. This sounds like a division problem to me. So we have $31.76 divided by 4, which is going to be $7.94. This is a combination problem here. Maria buys 6 bananas that cost 22 cents and 4 oranges that cost 49 cents. What is the total cost? So we have 6 times the cost of each banana, 22 cents, plus 4 times the cost of each orange, 49 cents. Simplify, follow the order of operations, multiply first, make $1.32 plus $1.96. Now, when you have these types of problems here, it's a good idea to set up the problem on paper so that gives you something to look at as a guide. Don't try to carry it all in your head, because you've got multiplication going on here and addition going on here. So the total cost is $328. And that is the end of 5.2.